Hello everyone, this is Sana and I'm a community initiative lead at Recro, which is a developer-centric organization. And what we are essentially trying to do is connect the right talent to the high-growth startup in India. And we're working with startups like CureFit, Udan, Swiggy, Dunzo, and many others. Today we have with us Ankush Sarkar, and he is a technical co-founder at UDEC and had been a part of Hotstar as well. He having around 7+ of industry experience, majorly into web development. He works with JavaScript and frameworks like Ember, React, Node, and many others framework as well. So here I'll tell you about the platform as well. So if you can see the right hand side, so right now we are using AirMeet, and in the right hand side you can see a raise hand option. So at the question answer session time, you can raise your hand and I can allow you the access to come here and talk. Your video will be visible and you will be able to talk here. Now you can see a chat box as well, wherein you can chat, and there's another option of questions. So I would appreciate like if you can ask your question in the question option, so that we can segregate like when you're chatting and when you're asking the question, so it would be easy for the speaker to manage the questions. Otherwise we might miss out any questions. Okay, so that's it about the platform, and I'll just ask Ankush to start the session, right?
Sure. Thanks, Anna. Thanks for the introduction. Hey, guys, let me share my screen real quick and then we'll start. So screen share, and we are ready to go. Awesome. So welcome, everybody. Thanks for coming out at 4 p.m. on a Saturday. We seem to have a lot of folks here, a lot of excitement around this topic. This topic is something I really enjoy, not just teaching, but also implementing. I've implemented this in Ember and I've done this in React in my previous companies. And there are a lot of confusion and a lot of tricks about how to set it up the right way. So hopefully I'll make it easy enough for you guys to understand the main concept and set up a production ready app from the get-go for your companies or your personal projects. So, it's called server-side rendering, but as you guys have probably seen in the messages we've said, isomorphic apps or universal JS, that was a lie. All these three things are basically one and the same, with some concepts here and there which are a little different. But overall, if somebody uses one of those terms, they're pretty much the same. So we are just going to call it server-side rendering from now on. So who am I? So I did a quick introduction about myself. So my name is Ankush. I've been, like she said, a web developer for more than 7 years. The first web development experience was at my company called UDEC in Los Angeles. I started that when I was still doing my master's in computer engineering. And after that, I joined Hotstar for a little while, where I was a web developer and worked on some really exciting projects there. Awesome. That's a little bit about me. In my free time, I generally prefer to teach and mentor a lot of new budding software folks. So, if you're somebody who's starting off in the field, or you are, a college fresher who's looking to get industry skills before you graduate, definitely come talk to me. So web apps, right? We all love them. They give us so much value. We're able to access so much content because of them. But how do we actually go through a web app? So we have a browser. Everybody knows one of them. We have Chrome, Mozilla, Firefox, Internet Explorer, or any special browsers you use like Opera Mini or Brave or whatever. So in a nutshell, a browser requests a web page which is hosted on somebody else's server, and it magically comes to your machine and gets rendered, and you see content. Great. Unfortunately, for people who work behind the scenes to make this work, there are a lot of challenges, and we are going to cover one of them today. So how is a typical React app different from a server-side React app? Like, why should we learn this extra thing to maybe shave off a few seconds here and there in order to our app to render faster? So generally, when we talk about React, we talk about a client React app, the React app which goes to a user's browser, and then from the JavaScript renders something visual which the user sees. So typically, in a nutshell, the browser requests the web page. The browser then gets the file, and from the file, it has to now request a JavaScript file. And that JavaScript file boots up on the client's machine. And it basically forms the visual components and elements which you see and interact with in React. And after that local app boots up, it has to now fetch requests, because you must have seen React apps which when they downloaded, they show spinner, they show loading indicators. In the background, they're fetching data which they have to now then render and show you something useful. So then the client requests data from an API, and then you see the content. So that little arrow which I showed before has now become many steps. And you can probably imagine that each of the step takes a little bit of time in order to get done. And that is what we're trying to do. We're trying to reduce these number of steps so that we show users something good and something contentful from the get-go. But there's a small hack, not a hack, but a small modification which we do. So these processes, they still take place, but the user is still happy. And we'll talk about how that happens. So we want to see our content quickly, right? Somebody sends you a link. Maybe it's a tweet from Taylor Swift where something major has happened and you want to read that, or maybe it's an update about, let's say, the COVID situation, or maybe it's a movie link where you want to like go and see what the text about the movie says. So even before your movie starts playing, you are interested in digesting some content about what you're going to see in that link. So the more that is delivered to you faster, the chances are high that you're going to stick around. And this matters a lot. So Google did a study, and they found that 53% of the mobile site users, if they abandon the page if it takes 3 seconds or more to load. And think about it, like people are not ready to wait even 3 seconds for a page to load from maybe like across the world on a server machine hosted somewhere else. And this matters because if they don't see something and they don't start engaging with the content, you are going to just lose users. There was some research done by an independent study which said, every 1 second that Amazon slows down their pages, it costs them almost 1.6 billion in revenue. And I'll link to these articles later so you can take a look. But basically what I'm saying is seconds matter when you load your web pages. So why server side rendering? Like we already said, we want to see things quick, right? Yeah, that's a good reason, but there's more to it. That not just the speed, but you can think of a typical team to be made up of different uh, units or teams or services where they all interact with each other. So your page has to constantly update, but oftentimes you don't own the APIs or the services from which you update these pages. So for example, imagine that on Twitter, right? So the tweet you say might come from a different database and a different service compared to the number of likes on that feed, versus when you reply to it, it might go to a different service and get saved in a different database. So you have to ingest a lot of different APIs and then show the user something. So that is what we're going to manage in our SSR app today. So this one example, so let's say there's a concert site which we are building. And the basic idea is we want that concert site to be extremely fluid and extremely responsive, responsive in terms of the data getting updated. So a single site can can have data that is updated from multiple places. So for example, the marketing team maybe pushes out a new ad which goes to the website, or a content team says a new event has occurred, or you have booked tickets, so the number of tickets which were supposed to be shown on the page has decreased. All these things change what your site has to now show. And because of that, we have to render new HTML somewhere, maybe through JavaScript and Ajax call, and then update the DOM, or maybe the first page you show as a static site is updated. And we'll take a look on how to do that. So what do we need, right? What do we need for this SSR to take place? So we need that when the browser requests the page, you load the React app not on the client's machine, but on your own server machine. So in your node environment. And if you send that page, the user still has to make API calls in order to show something visual. So you have the booted app, but it's still empty, right? Like the spinner is still there. And now you have to wait 3-4 seconds to see some content there. So we want this fetch to also, like this data to be fetched also on the server side. And then when we have this, we render a basic version of the app, which we generate the HTML from, and we show that to the user. So when the user sees the first HTML page, not the JS, not the CSS part will inject the page, but we don't wait for the JavaScript to get downloaded, get parsed, get executed, and then the JavaScript fetching its own data. We want the data to be already available in the HTML page. And when this comes to the user's machine, they can immediately see something visual. Now, there are small caveats to this, and we'll discuss that as we go along. So before we start with how we build this render server, right? Because this is different from our API server or a database server. This is just a server whose whole job is keep the HTML page of your apps, and in this case, a React app, updated for the user to see. So imagine a typical server is made up of different components. So you have databases, authentication layers, you have logging, authorization, security, many, many more. And if you try to put our renderer in this server as well, and by the way, this does happen, right? Things like in Python, in Flask, or using some framework like the PHP Laravel and or whatever. Like when you couple your view layer with your basic APIs, it works for the beginning, but then when you have to now change and move to a different model, maybe you are going for a service-oriented architecture, or maybe you want your front-end team to just manage their own product, it becomes extremely difficult to manage that server because everything is just coupled together in the single server instance. So a good idea is, instead of this to exist in with the rest of these services, you separate your renderer server and you separate where your business logic data, whatever you were using previously, keep it separate. So this renderer server, its whole job is to create the web pages. It will fetch these details from your other servers, create the page, and give you the page. That is all it does. And there are benefits to that. So for example, let's say you have multiple APIs and you have your rendering server. So now when a user asks for a page, that rendering server can take care of it. And if, let's say, you have to develop multiple kind of pages, or if there are multiple security restrictions, or there are multiple users, you can just throw in more rendering servers who are talking to your backend APIs and get your work done. So this helps when you separate your concerns here. So what will we do? So we will start basically to create a React app and then move it into a server-side rendered app. To do that, we need to do a couple of things. So first, we obviously start with creating a simple React app. After that, we have to add some kind of basic server-side rendering and get a simple HTML, which we can see on our browser. After which, what we're going to do is we're going to add a router, because if you have a React app that only stays on one route, it's pretty much useless. Like, we have to deal with a lot of links. And then we have to make this router work with SSR, which is a challenge because if you remember, the React router or the browser router which we use, it has to be booted up in a React JS environment, and it reads your address bar to determine where to send or load the next component. And that might not be possible on server side because remember, our app is not booted up, and guess what? There is no address bar. So we'll learn how to make that work. And then, of course, like most people, when they talk about server-side rendering, they pause there. But if you have a Redux app, you still want to use your Redux app, right? You're not going to say, oh, because I want server-side rendering, I'm just going to throw away Redux. And that is where the meat of the problem is. And that is what we'll tackle one by one. And hopefully, if you just learn that part, it will help you quite a bit when you try to implement this on your own. Then we'll have to load the data before we send out the HTML to the user. So we need some, because if you remember Redux, right? Redux has all these action creators and actions, and they go into your store, and the store then updates the data, and there's a provider tag that automatically updates and gives it to a component. That cycle doesn't work very well on the server side because nothing is booted as a client app. So there has to be some way where we realize when the data has finished loading for the component, and now when we can start generating HTML. Because remember, this is different from React, where you've loaded a basic version of the app, then JS runs, fetches the data, and then updates what you are seeing, and you have the visual content. We want that visual content to come up first in the HTML. And then we'll work with some page meta and things like title, how to update stuff, and some SEO, because that is important. A lot of people tout SEO as the main reason we should do SSR. It depends. Like, every time you have a requirement, you have to evaluate if it makes sense for what you're trying to build. So evaluate if SEO is really the reason why you need SSR. Maybe there's something else. Maybe you have a lot of users who are coming from villages with low-end mobile phones or bad network, who want to see information pages quickly, and that is what you want to help them do. So learn these as skills and then decide if it fits the problem you're trying to solve. And then I'll probably share a little more bonus tips before we go, because who doesn't like more free goodies? So React gives us this function called render to a React string. More specifically, React DOM gives us this function called render to string. So what it does is, if you give it a component, it will give you a string version of the HTML markup of that component and whatever that component uses. So basically, it transforms your React app into an HTML page. But like I said, if you immediately convert your React app into an HTML page, you will not get those components which are rendered after you have fetched some data. So we'll learn how to use this better. So we have a simple React DOM. And like we've all used the render function in React DOM. Without that, we can't really make a React app very well. And similarly, in that same package, we also get renderToString, which we can use for our purpose here. So let's start with a little bit of code. So, all right, I'm going to go and just start off with a basic version of my app. So I'm using the typical create React app. I hope everybody can see the screen. Otherwise, I'll just make this a little more big. Hopefully, you can see it now. So yeah. So basic stuff, app.js is there. You get a lot of boilerplate in that. I've not changed very much here. Maybe removed a few things here and there. And you can see there's nothing in the app. It's pretty much the old stuff, old known stuff. All right. So I go to my terminal and I say start. It's going to run your server for you. It's going to set it up in the browser, and we'll see an app here. And this is our very dummy app. So the app we are trying to build is, I'm calling it Concert Buddy. What it does is basically helps a company manage all the concerts and ticketing in an area near you. So any local or international concerts that come up, you'll be getting tickets and event notifications there. And you can just buy your tickets and see what is trending, and you can see like a list of remaining ticket prices and stuff. The reason that is important is when you go to a page, you immediately want to see what is the hottest concert that is still going on, what concert is available in your city. If you're going to a concert page, you want to read details about it. When is it happening? Who's performing? Who are opening? What is the ticket price? How many tickets are left? So the quicker you get to those details, the more you're going to engage with that page. So, all right, typical React app, nothing much to see here. So how do we get to this React string? Okay, let me quickly go up here and so what I'm going to do is I've already created a PR. I'll send this link to you, but the purpose is it will make it easier for us to see what changes I've done, because if I start coding everything, I might run into a few bugs here and there, and it might confuse you more. So I've kept things extremely simple, and we can start off with the basic of commits and make incremental code changes as we go along, because frankly we are limited a little bit on time. So first and foremost, what we are going to do for our server-side rendering is we are going to set up an Express server for ourselves, because you need a running server who can read your app and convert them whenever it's asked and give you an HTML. So we are going to host it somewhere. So this is my local Express server running at port 4000, and it's just going to say hello if I access it. So pretty basic stuff. I think most of us have used this before. So let's go here. I'm just going to quickly set my code to using the Express server. It's going to complain, let it complain. I think I have the package installed, but just to confirm, I'll just quickly do it once. All right. It's going to take a while. Anyway, so yeah. All right, so let's see what our package.json has here. So you can see that I have Express here, and I've readied the script. So now what I need to do with that Express server is to create a server index file. So basically, if I run this index file, it's going to start that server for me. So what I'm going to do is node server index, and it says listening on 4000. All right, so let's see, where's my browser? So this was our React app, right? 3000 was the port where our React server was running for just the client apps, but I'm going to go to 4000 where I ran my Express server. So you can see that I get a hello response, which is what I had set up in the code. Right, pretty basic stuff, nothing much to talk about here. If you have any questions, just put in the questions and we'll get to it. But now that I have my Express running, I have to now help Express to understand what a React app is, because I'll tell you why. So see this little bit of piece of code here. So I'm going to import this renderToString function. So require React DOM server app.react.toString, renderToString, which is a function available in the DOM. I'll have to use require because most of the Node versions right now only support common JS modules. They'll not support the CS 2015 modules, which we are so used to, import something from something. And then I'm going to import my basic app component here. So app component require app default. And I'm going to try to just put the app component here and say renderToString. If I try this, it will fail. And the reason it will fail is because our Express server right now does not understand anything about JSX components. So what we'll need to do is create a Webpack file where we install our Babel loader. And we'll create a server bundle file, which will take everything from our JSX code, put it in a nice little bundle. I'm calling it the S bundle, so like server bundle. And as we go along, we'll also create a client bundle, and you'll see how we're going to use it. And to help with my work, I'm going to create this script called dev build server, which will start the server for me. And let's go ahead and do that. So I'm going to skip one commit here because there's nothing much to see there, and I've already spoken about it. All right. So stop this. Quickly install everything. Actually, guys, what? I'm going to just go to the last commit and install all the packages once and for all. So I don't have to keep doing this. In the meantime, I'll run you through the slides. So what we're going to do is we're going to set up Webpack and Babel for our server-side rendering. So once we do this, the server can now understand the JSX syntax. So it can understand components and what they need in order to render to string and etc. And like I mentioned, the common JS will only work, and we'll not be able to use ES 2015 module just yet, but that will change soon. So if we take all our components and run it through our Webpack and then run it through the Babel loader and create our bundle, which we are calling the S bundle, server-side bundle, we'll be able to run that server-side bundle which we have created, because it's going to have all the code from Express and all these action.js, home.js, whatever code you throw as components, it's going to be there. And we'll just use our Node runtime environment and run it. So the problems we had were JSX files were on server, and we had to create an HTML out of it, and we solved those. Now, the reason why we want to create two bundles is because when we work with server-side code, we may also be working a little bit with the server-side secrets. Because let's say we are creating an admin page for somebody who's already logged in. That person will have sent in some kind of authentication which we would have cached, or we would have known through some token who that person is. We'll be using our API secrets to hit our API and create that page. So sometimes you want to keep some code which is specific to the server in the server-side bundle, which is different from our client-side bundle, because we don't want to expose that code onto a user's browser, because then they'll just create some security issues. So we'll create two bundles, the server-side bundle, which I'm calling the S bundle, and the client-side bundle, which I'll call the C bundle. All right, this seems to work. So, okay. Yarn lock is complaining. Awesome. So if you now see, I have, if I go to my source file, let me just use this. So if I go to my server file where I created the index, I can now, I'm importing the same thing, renderToString, React, Express, whatever I needed to get it running. And all I need to do now is, again, start my server. So remember that was node server index.js. Oh, sorry, no. Now because made the wrong commit. Run Webpack. Yes. So what I've done is to use Webpack, I've also installed this little command called dev build server, which is going to create the server for me and put it into a build file where I'll use it from. So I'll do yarn run dev build server. I'm going to start Webpack. Awesome. So now I can do node build, and you can see we have an sbundle.js. So again, as you can see, when I run this bundle file, it's going to listen to the port 4000 again, because every code which we had has now gone into our um, bundle file, and I can still run, and I can see an app.js showing up. So let's inspect. My J key doesn't work very well. Okay, so basic, we can see what our page looks like. So we can see, okay, it's having a div, which is app.js and body, and it's there. Now what we are going to do from now on is we also installed our Babel dependencies, the usual stuff. So what happens is if I have to run my server-side setup, every time I make a change, I'll have to go in and restart my server so that it gets the new code into the executable, and then it will run it for me. So what I've done here is I've created 3 commands. I've installed nodemon. So nodemon will watch over my files, and whenever they change, it will just restart my server for me. And similarly for Webpack, I've added the watch command. So every time I change something in my components, it's going to also create the new build for me. So this way, I don't have to keep going in and running the servers myself. I can just run these commands and I'll be good to go. Now, because we have run everything through Webpack, and Webpack has a Babel loader, the final server bundle is compatible with your node environment. So now I can start using the import syntax in my server-side files, which is good because when you're working with client-side and server-side files, you don't want to use 2 different notations. You rather keep everything consistent. And because I'm already using import in my client app, might as well use it in my server-side app now, because Webpack is already going to translate it for me. Cool. All right. The other problem I'm going to have is once I send this code onto my client machine or client browser, if I try to do any events like clicking buttons or submitting events, they are just not going to work. And the reason is when you boot up a React app, React also attaches the event listeners for what you're doing. But in case of your server-side rendered app, it is just an HTML markup. There are no events in it. So you need to do something in order to make your events work. And basically that step is called a hydrate step. So hydrate step, I'll show you in code what it looks like. So if I go back here and let's say this is, I said, okay, button, there's a button and button on click, which just console something. This is not going to work right now on my client machine because we've not done the steps required in order to hydrate our events. So what I'm going to do now is also create a webpack.client file. So I'm going to use Webpack in order to create a bundle file for client and then hydrate events myself. And we're going to start using that on the server side. And in order to do that, I've also created a config, which is the config webpack client.js. There will be some config which is common between client and server. And what you can do is use some kind of a merge plugin later on to keep a base config and import. But for purpose of this tutorial, we're not going to do that because we also want to keep time for questions. And what I'm going to do now is instead of keeping renderToString in the index page, I'm going to create a separate file called the renderer. And I'm going to move all the rendering logic onto that file so that later on working with it becomes easier. And then the render file will basically generate my HTML for me. And I'm going to throw in the content there, which the content comes from rendering the string of app component. And once I have that, I'll get the HTML page. And for my client, what I'm going to basically do is I'm going to hydrate it using the hydrate command. So instead of doing react dom.render, I'm going to do react dom.hydrate. And let me find that for you. So there's a client bundle there, renderToString. And also what I need to do is because client bundle goes to the user's machine, I will have to publicly expose that. So I'll have to use express.static in order to allow client.bundle to be downloaded by the user's machine on their end. I know this is, we're running a little bit because next thing onwards, I'm going to show you how that works together with a single command. So we don't have to confuse ourselves with 3 running server instances. Like right now I have to run a server for Express server. I have to run a server for generating the server side bundle, and I have to run a server for generating the client side bundle. We are going to combine this all together and just have one command that is going to do it for me. So, all right, you can see that now in the renderer, I'm starting to send the client bundle onto client's machine. And we'll run through code in a minute. So don't worry, I'll show you different steps as we go through our code. And in our index page, what we are doing now is instead of .render, we are going to call .hydrate. So let's see what happens to our app here. So I'm going to go through this, run all commands together. So, okay, back to code. So if I go to my code now in my package.json, you will see that I have installed package.json. What happened? Console buddy. Right. So you'll see that I already have my old commands here, right? The client, build watch, the server, the build server watch, the three commands which I had to run before in order to get my client bundle, server bundle, and also my express server running. So what we'll do is we'll use this command called npm run all and say minus parallel, which is run everything in parallel of whatever command has a def colon in front of it. And we can't use multiple colons because sometimes there are complications. So you can see I have converted my command into hyphen. So what this is going to do, this command is going to see my scripts, and it's going to see scripts that start with def colon, and it's going to execute all of them. So it's going to run this and this and this together. So I'll show you what that looks like. So back in my app, all I have to now do is npm run dev. So I don't have to do any of those long commands anymore. And you can see that it's running three commands behind it, and it's giving me output from all these three commands combined. So I can see everything that happens from these three commands on my side, on my machine here. So, all right, let's go back into my app here, load it, and you can see a basic server-side rendered app. So the reason why this works is you can see that in the HTML, there's already a few tags which have come. And if you've inspected a React app, this is not what happens on the first load. And I can show you in the network tab. Let's clear everything up. Let's load this again. So it's going to fetch this file from localhost. And you can see the localhost file itself in the HTML form has our HTML here. If I go to the console and I click this button, now the button works because we use the Hydrate command in order to attach the listeners for everything that the React app needs to now handle. So let's jump back to the presentation. And now let's talk about putting in a router, because so far this is pretty basic stuff. Like anybody with the tutorial can just jump in and do this very quickly. So in order to install the router, so this is where I said I'm going to put my commands together. So you can see that I've installed basically this new package called npm run all. I hope you guys can see my screens. I have not been checking for any questions. Maybe I should do that. Where is the Git URL? I'll share the Git URL soon, Harshit. Okay, awesome. Cool. Sorry, my screen changes a lot. I'm not used to working in one screen. I use multiple screens a lot. So, yeah. I'm also trying to condense a lot of like code sessions into one session so that there's a basic understanding. And what we can maybe do is a live session some other time, and we can everybody can we can all sit together and set this from scratch. Another thing we would like to add to optimize our bundles is this thing called the node externals. So I told you, right, we take the Express server and we put all our React components into it, and then we use all the packages and import them into the one server bundle file. Now, for client, that makes sense because client needs those bundle dependencies available in the final file so that they can execute them. But if you're running something from the server, we already have that code available in different files. So why should we again take that code, bundle it together, optimize it, and then run that executable? So there is this helpful little package called Webpack Externals. What it does is it removes code which is available in your server side locally. Excuse me. So what we'll tell Webpack Node Externals to do is basically go over every file of JS or JSX type except the ones in Node modules, because we already have Node modules available in our server side. So one more thing you guys need to note is when you create a config file for server-side rendering, you have to give it this target node so that it knows that this bundle which it has to create is for a running node instance, not for a client-side browser. Just to make things a little simple, the entry point for our client bundle, and we are going to start calling it client.js, not source index, so that as we go along, we have a good understanding of when we are doing something in client and when we are doing something in the server. And now in order to do some routing, we also need to install the React router DOM. And typical import browser router from React router, and this is how you set up your basic routes. And then you import your switch statements, which say, okay, if I go to this path, load this component. This is what we do in React anyway. So I'm going to just run over this for now because we need to go to the server side of things. Now coming back to our server side. Now server side needs to know for which path it needs to generate which components, or basically generate what markup. And if you remember, like we spoke about the browser router, the browser router can see the address bar. And if the browser router can see the address bar, it can quickly get the URL and do whatever kind of replacing and or hashing it has to do and show you the right component. But on server side, we will have to give our router a path so it knows which component to load from that path. And again, just like how we had a render and a renderToString, similarly, the router gives us a static router and a browser router. And the static router works on your server side, and browser router we've all used on our client side. And what you do is you create a route file which is shared with both of them. So the route file, basically the routes you can generate is the same for server and client. So you don't have to worry about that. So once I have this route available, I can see if it's working for multiple paths, and it does because it is the general client-side router anyway. Now we'll have to set up Redux with all our fetching of data. So let's do some questions if we have them, and then we'll move to the important part, or maybe the hardest part of getting a server-side render setup running.
Yes, Ankush, we are having questions here.
Okay.
Avinash has asked, does React Router help SEO for SSR?
Yes, we will cover that as we go along. It does help, and I'll go over the details of that. So where is that question? Yes, so let's mark it. So if he hangs around, he'll get an answer for that. I have some slides on it. Can you please elaborate on how Webpack helped you using directly import? I might have missed it. So if you remember, Yash, in order to run the Node environment with the components, because Node does not understand JSX, we had to put in Webpack and Babel, and that converted your JSX components into your old JavaScript code. So Node can obviously understand that. And because now you're using Webpack and Babel to basically transpile your code into the old form from the ES 2015 modules, now that means if the executable, which is our server bundle.js, that has only JavaScript code, not the new format. So now Node can run it very easily. How do we know whether a particular app uses SSR or not? So if you notice, when I did the SSR and I went to the browser, the first page, the 200 OK get request, which I got of that page, already had content loaded inside of it. So for a typical React app, that will not happen, because what happens is your HTML will get passed. It will find the JavaScript file. It will ask for the JavaScript file from that server. Once it gets downloaded, then you will go through your JS, the JS code, which has the components, and then they will then create your DOM elements. So the initial HTML which you have will not have your components in it. Why 3 servers? Only 2. One to provide server bundle, one to provide client. Yes, and one to run the Express server, which executes the server bundle.js. Third one is for running the server. Yes, Express server. You're right. DevTools network docs. Not sure what that is.
I think
Why are we doing? Ashutosh asked, why are we doing app.use express.static? Very good question. So when we create the client bundle, we want, maybe I'll show it to you in the code itself, so it will become easier for you to understand, because I skipped a lot of code because we're running out of time. So let's see. where is my index file and where is my render file, right? So in my render file, I'm now sending the HTML, which will become the client React app. And you can notice that with the content, which is my markup, which I want to show the user, I'm also now giving it the opportunity to become a React, or not the opportunity, I have to give it this ability to become a React app, because once the basic HTML comes, we need the events, we need the user to be able to go to different sites, render more components, fetch more data, or whatever the React app does. So I have to send this client bundle.js. And this client bundle.js has to be obviously accessible over the internet. Otherwise, it will not get downloaded in the client's browser. And in order to allow that, instead of putting in the build, I generate this in the client bundle. So you can see this entire file that gets generated. And this I'm putting in a public directory. And I'm telling Express that if somebody tries to access the public directory, let them fetch the files from it, because I want this public directory to be available over the internet. Oh, somebody already answered that. Which is the best place to load JS bundles? Is it the body tag? It depends what you want to get done with the JS tags. If there's something you want to run before your elements start showing up, you may want to put it in head. And if there's something you're okay waiting after the DOM, you put it in the end. What does Webpack node externals do? So Rajat asked this question. It's a great question. I know I skipped over it because, again, we have to make sure we reach the meat of the session. So when we send something to the client, we have to import every dependency. So for example, if you're using Lodash, you have to import Lodash into your code so that it can execute, or you have to give it a location to the Lodash file and download that file and then run it. And generally, we like only send one JS bundle. So we put everything together, even the third-party libraries or in third-party, or not third-party, but our other team's code together in one bundle and send it. We sometimes do tree checking on it to use just the code which we need. But when you're running something on the server, the code which you're going to send is already available in your the node environment. So why copy that code into a separate server bundle and then run it when you can just run it from the node modules? So Webpack node externals basically lets you have a smaller server bundle so it can run fast and not do these unnecessary steps of going through the node modules and optimizing it, because that code is available in the local machine, so you can just call it from there. So it reduces the size of your server bundle. So it gives you some optimization there. What is the real advantage of SSR? Because you have various ways we can optimize the load of the page. The biggest advantage, like I showed, and I will also show you in future, is the first page that comes to you has content in it. So before it becomes an app, just the site itself gives you value, and it's better than seeing a loading spinner. Even the loading spinner you will only see once your JS loads, because the JS bundle will have the code to create the spinner and show you the spinner when it's fetching other data. So typically, if your network is slow and you only get the HTML page, you are just going to be staring at a blank page for a long time. But let's say if you have a page and you can read something on it, and in the meantime, it can load something in the background, that is a better experience to the user. And like we said, like the latency it takes and the time it takes for the user to start getting value from your site, maybe not 100% of the value, but enough for them to keep them engaged. The perceived speed of the page may differ from the real speed of the page, and that enhances your app's experience. Can we get HTML viewport size on server for creating HTML by renderToString? Well, typically we want to write our code which is responsive. So we just want to create the markup and we want the browser to handle the kind of pages it shows. But yes, you can, like I can put CSS in place, which can say, this is the size of my final components. Working with and without SSR has effects in application. It does have effects in application. And right now, there are not so many you saw. But now when I start to get Redux working, there will be some effects here and there. So we need to know those. Pagination, lazy load, PubSub model from various other devices. We can leave that. What is the use of Next.js? It's a different framework which makes it easier to load your components. Why separate renderer.js? Because if you have a server express file, it may have a lot of code which is doing other things like security, API call, fetching this, that. We don't want our file to grow too long, so we'll move the renderer code into a renderer file, so it's easier to know where to find it. Oh my God, the big question. What is the view
Yes.
meaningful paint? And if the initial load is going to be rendered, content animation video, impact the page performance, whether you on desktop or rendered. Okay. A lot of questions. It's still hydrating. Yes. So again, if you in the next slides, I will show you. So what you do is when you load the components, you determine which data is important to give you meaningful content from the get-go, and you fetch that from the server and send. And in the meantime, you can load something in the background. So for example, let's say a Hotstar video page, right? If you go to the page, you want to read the details about the movie you're going to watch and maybe some more details about what's coming next. The video player may not have initialized, but you started coming to the page and the page loads instantly. So you know things are working and you're bound to stick around. So you are loading something like a skeleton of the page. In the meantime, your main like live heavy components will start taking in on the client side. Sitecat, Gatsby, create static sites. Can we have two SSR pages in single React app? So everybody wants to know what I'm going to teach them next. Okay, cool. I'll tell you. I'll have slides for that. Partial versus complete hydration. It's generally complete. Is it good practice to use SSR on large scale app? Yes, definitely. And I'll go through it. So what I'm going to do now, I wanted to show a lot of code, live coding, but it seems you guys have a lot of questions on what I have to tell you anyway. So we'll go through that. And then when you have questions, I'll show you in code what these specific scenarios were to fix that cases. So let's do that. So Redux challenges, right? Obviously, we are going to use some kind of state management and we are going to fetch details and APIs, like we said before, to create interesting visual, important content. So for Redux, we'll have to create, again, just like router, two different configs, router or Webpack, because it's going to work a little differently in server versus how it's going to work in the client. Then we have to wait till the important data that has to be loaded in the HTML. So important is something like which we discussed in the previous question, where you may have 10 things you have to load, but maybe if you load the first 2 or 3, it gives value to the user. So you want to load that first. Then you have to do state rehydration. I'll show you an example of what that is. Basically, when you have something on server, the data which you've fetched, you have to find a way to like send it to your client as well. Otherwise, client has an empty set of that data and it will remove those visual elements from your view, fetch the data and then show it, which is useless for our purpose. Authentication related proxying, we are not going to go through it, but it's basically how, if you had to create authenticated routes and create the SSR for those, how will that work? So first 3 will give you a great idea of what to do. Current scenario, right? Current scenario is, let's say if we have a React app, we render a React app, which is going to mount our component. Now that component is going to fetch some data, because that's usually where you do something like this.props.fetch users or fetch apps or whatever. And that takes time because it's going to go over the network, hit the API, get you that data, and then we'll show that data for the user. But if we're using SSR and we don't wait for the data to load, the first version of the HTML will get sent to the user, and none of this later part would have happened. So user will get almost a useless piece of HTML over which they'll have to again wait for the calls to go and the data to load. So the benefit is very, very low unless like you had static markup and you were okay sending that. But because we are good engineers and in our cases, we have some complications. So we'll now talk about how do we wait for that fetch data to happen. So what ideally we want is we boot the React app on our side, we call fetch data on our side, we render HTML using that data we have fetched still on the server side, and then we just show user the contentful HTML. So that is the difference which we are going to create here. So we're basically going to find a way to wait for the data to load on our server side and then create HTML and send it to the user. So what we're going to do is we're going to create a load data function. We have to find a way to not let the route load, but still find out what components are needed for that route. So if you remember in client side, our router loads the component at that route, and that component then goes to its componented mount, and we fire all the calls which we need, or we basically after the route, we decide what data to fetch. But here the scenario is different because we don't have a browser router. And what we want is we want to fetch the data before we load our components and create the static HTML markup. So we need to like figure out which components and which data we need before we go to the components of that route. And once that data is ready for every component belonging to that particular route, because an all concerts route will need data very different from trending concerts or maybe from a concert ID route. So things differ there. And then we render the HTML string and we send that useful, contentful HTML to our users. So what we'll do is in server.index file, we'll create that load data function and pass it to our Redux store. And instead of using a provider and the connect syntax, we'll manually dispatch our action creator from which we'll return a promise to our Express server. And because it's a promise, we can do promise.all, collect all the promises together, and we'll know, okay, let's say if this component needed 5 data to be fetched, we'll wait for all those 5 data to be fetched, and then we'll render the HTML. And I'll show you in the code where that is. And the reason for that is when you had a provider in the client, the provider already was connected to your store, and all you had to do is tell the element I want to connect using this part of the store. And whenever the data updated, the provider tag would automatically fill in that data for you. So you didn't have to do anything. But because we've not created our app yet, we don't have the provider ready to fetch those data for us in the store. So now in server, this concept is going to change a little bit for us. So like I said, we create the action creator, which will send the action. The action will manually dispatch the store for us. This will not happen automatically anymore. We'll have to say store.dispatch this action, and it will trigger, fetch that data, load it for us, and store will be ready. And then from the store, we will create the all the HTML markup which we need. I know this is confusing, but from code, it becomes a little clear. So let's say that we had 3 components on a route, and all of them, because we need to know what data all those components need in order to load. So we'll wait for all of these components to fetch their data. And once it's ready, we'll then have our store on the server side full of data, which we can use to create our HTML markup. So code, let's skip this for now. The basic idea is, at this point, when we are now sending the HTML to the user, our store has data. So for example, I'm using all concerts. That state knows it. So I'm going to be able to put it in my HTML, and I'm able to show it to the user. So let's go to the code and see this. Let me walk you through the code one by one, so that in case you have doubts there, we'll catch those. So all right, basically what I've done is I've created a mock API called all concerts. All it does is it gives me back a few concerts and with their IDs and names, which is important. So for example, it says, okay, whenever I ask for that API, I'll just delay it by 3 seconds and give them the data. And I've installed Redux and Redux Thunk, so I can use it, of course, and React Redux because I want to use the provider in the client side. And now I have to create a server store on my server. And this works a little differently. You'll see in the code as we go along. So basically now in my Express server, I say, okay, when you are finding all the pages, create a store called the server store. And when you generate the HTML, pass this store into it. So we can read whatever the store has and create a markup based on that. And on the renderer side, I have used the static router, which is given to us by the React Router DOM. And this is different from browser router because here I have to also tell it which path you are going to, which is different from the router where it sees the address bar and decides which component to load. And now when I generate my content, I'll also give it the store, so it can go to the store and create and fill in the components with whatever is needed. And then nothing, like I'll create simple actions which are going to get all the concerts and dispatch the events. Basic React stuff. This is all React stuff from here, so don't worry about that. So after this, when I share the link for this GitHub page, you can just go through every commit one by one, and slowly you will realize what is getting created. And Babel polyfill. So what will happen is you will use async await somewhere, and it'll say regenerate a runtime not found. That's because when you're trying to run it, it doesn't know the async await command. So when you do Babel polyfill, it will start working. So you have to use actions in order if you want to use async await over there. So basic fetching all concerts. There's just some typos I made in the previous commit. I fixed those. All right. So now to show these concerts, I have to fetch all concert and maybe make a new all concert list, which is nothing but a UL element, which is rendering a list of LI elements. So the store will get created. The store will have data. We'll read from that data and populate this list one by one. And nothing map state to prod, simple connect stuff, basic React environment. And I created this all concerts page. Now the difference here is we cannot use our routes in the old format. So let me show you that first. So our routes, which we had as a set of route tags in a switch component, we are now going to change into an object format. so that we can ingest that into our server-side files and use the render route which React DOM gives us. So let me show you render routes. So again, not React DOM, sorry, React router config will give us this React router render routes. So when I pass the object into this function, it's basically going to create that old routes and switch statements which I need, but internally, so I don't have to do it myself. And this will help me in stopping this route from loading before I have my data ready. So I'll just now throw everything into a promise, and after everything is loaded and promise.all resolves, we are going to load our component or load our markup file, which is ready to show render to string function. So back in our express, I'll use the match routes. So for every route, it will basically give me that object we created before, which says, okay, this route needs these components. And once I have this all match routes, I can go over them one by one and see what they need to load. And I can put that all into a nice promise array. And then I can just do promise.all. And when every data is loaded, I can now send back a generated HTML page. So, and then again, like on the client side, we'll do the same thing, connect everything and send it. One more thing which we'll do now is we'll start sending a load data function from our component. And what this load data function tells us is what data is needed to load this component in order to render its markup. So when we go into that object, we can just destructure it and get our load data function from there. So I'll show you, like for example, in this case, because remember I told you we have to dispatch that store action manually. And this is the critical part of using Redux with server-side rendering, which is we can't like rely on our component will mount anymore, because that will only happen on the client side. Come on, I don't want that. So remember this component did mount for this component. So this will not happen because we are on server side. So there's no mounting that takes place, which will load the data from the actions for me. So we are going to create this manually, which is load data, and we return a promise which happens when the store.dispatch action takes place. And we'll use this load data function on our Express server to capture that into a promise. And for every load data, then we are going to render our site. So I know this is a little confusing. With a little bit of practice, you'll get a good hang of this. So the one problem which I told you was when this goes to your user, they will see a page in the beginning and the page will just disappear. And I'll show you that in my example here. Let's go to that real quick. All right. I'll run this again. Because the command, I would have tweaked something in order to make the new stuff work. So right, there's my Express server working again. And restart everything. And now I'll go to my all concerts page. And you'll see that there was concerts there for a second, and then it kind of disappeared the next time around. And then again, as the API resolves, it will again show me the concert. And this is important because if you don't catch this, then it becomes confusing later on as to why your server-side rendering is not working. So what I'm going to do is I'm going to show you that this data actually loads when I load my page. So this is my get page. It's still pending because on the server side, all the promises are still getting resolved. And once they're resolved, then the page will be formed. So if I open this page, you can see when the server sent me this page, I had my data here. But when you saw here, the data came and immediately React client app booted up and it tried to fetch its store, and its store did not have any data because we've not transferred it in any format. And it cleared that list for me. So automatically, because I'm using the provider component, and my store was empty, it removed these elements. It fetched its own data, which you will see in a network call. So let's try this again. So all concerts, it's still getting because it has to, again, resolve that promise on the server side, and client bundle.js shows up. And now it has resolved. Why can I not see this here? Okay. So maybe it has to make a call in order to see it. All right, I have to see this. But you can see that the data stopped loading for a little while. And after it was resolved, only then it gave me back my data. So we have to fix this if we want to have a consistent experience. The way we fix it is when we create this state, we send this state to the HTML as a basic JSON string, and the client will read that JSON string and use that as the initial state for its Redux store. Because we've already fetched that data, and it's probably not going to change in the time when the second call is made. So when the new store was created, it was empty. So we have to now send that store as initial state so that we can retain our state there, which is called state hydration. So this is similar to that event hydration we did before, where we send the HTML and we had to attach events to it. Here we send the state and we have to attach the initial state to our Redux app. So a simple way of doing that is basically in our server-side rendering code, what we do is we say window.initial store state and we pass that state into it. In some frameworks, we call it shoeboxing. So the initial data which is sent, we then take that data and put it into our Redux store. So I'll show you that in the code. So you can see that when I'm creating my renderer file, I am sending a new script, which is initial store dot state string. State string is nothing but JSON.stringify of store.getState. So it will get that object, get stringified, and that will now get attached as an HTML into the client's machine, which will save us from the problem of our list getting emptied the moment JS boots up and then getting fetched again. So on our client.js, you can see that I take the initial store, and instead of the empty object which we pass to create our store, I pass my initial store state so that it reads from that script from that object and then readies my store with some data. It will also fetch its call and get that data, but it's going to be the same, so it's not going to change anything. One thing to keep in mind is just because we have in our code a place where we are, let me just pull it up. Where is it? Source, actions, pages, all concepts. So just because I have a store.dispatch which is fetching data for me and it's coming up in the HTML page, you will be tempted to remove this from your code because, why do you want to fetch data twice? But what will happen is you will have more routes in future. And once your React app boots up, the React browser router is going to take care of the routing, not the server side. So if somebody goes to a different link and goes to this page, there the server side page is not going to get generated. There you will be using everything from your client bundle. So if you don't have this in your code, then it's never going to fetch from the API because you removed it from here, and this function never ran because that was not the server side rendered page you landed on. And to avoid, there are ways to go about it, and you can say, okay, you can read some flag which says, okay, I was server side rendered, so I don't have to fetch. But generally, to keep things simple in the beginning, make sure that you don't miss this. This is wrong. We still need it. So don't comment it out. All right. And now somebody asked about SEO, right? So for SEO, what we can do, the reason why we need to do SEO is it's a React app with different routes. And we are coming to the almost end of our session here. So now React app needs to have different links. And because if it's a big app across multiple teams, you'll have multiple routes managed by multiple people, multiple teams. And they all need to optimize what they show as the head information or like SEO purposes, what they're going to show when somebody shares that page, that link onto, let's say, Twitter, Facebook. Initially, like Google and Bing, they had problems crawling JS apps, but nowadays they have a system in place where they can render the links for themselves. But even then, you are still sharing your links around, and you want to make sure that you are fully optimized and your meta tags are populated properly. And even things like if, let's say, you're loading a list and you want to see in the title bar how many elements are there in the list, or when a notification comes to your LinkedIn, you want to see how many notifications are there, or a Facebook chat or something, that you have to update certain head elements dynamically. And in order to do that, what we can do is use this thing called React Helmet from the NFL, the National Football League, and they created this wonderful component for their React apps. And they also then created the server-side equivalent of it. So let's see. Let me go back to the code. So one more thing to keep in mind is when you do this React stringify get state, somebody can typically, I wanted to show you this, but I think we don't have enough time. So what we can do is as you're putting in input, somebody can inject /script and then start a new script tag and just write a function which, and because this will get executed in your JavaScript on your client, you can do some funny things with it. So as a precaution, to prevent cross-site scripting attacks, make sure that when you send this get state store, you serialize it, and you can use any library. Like you can use serialized JavaScript, which is basically it removes all the unsafe um, tokens from that, and it puts the Unicode equivalent. So your browser will still render it properly, but it will not be treated as an element when your browser renders the HTML page. And in case you want a component that renders every time, or maybe like it's a super component that runs in every single route below it, what you need to do is create in your routes object file, you create that app in the beginning, and then you create a routes object and you put your code there. So I just took all this old code and I put that old code as the array element inside the routes key. So when I do this, this app component will always load, and then on that route, whatever is that route component that will load. So for example, maybe you want a header and footer to always show up in your pages, but you want to load the main content based on what URL you are on. So you can employ this kind of a technique. And there's a way to implement not found pages as well, and you can tell the static browser how to do that. And I've written code here to help you like send a 404 status back when your page is not found. So now coming to React Helmet, right? So React Helmet, we need React Helmet obviously, and that basically gives us Helmet from React Helmet. So now what you can do is you can get all the head tags so the way Helmet works is you put your tags which you need in the Helmet component and inside every component file. And this, when rendering the file, this Helmet library will extract it out of your component and set it as your index head tag. So you can put all your individual title, meta inside the component, and when that component loads, and if it's in the Helmet tag, it will automatically become the equivalent tag in your head script. So same, yeah, like you'd say, whatever are my tags, get it into a static mode and attach them onto my head element here. So this is where I get all those head tags using React Helmet. And when I'm sending back my HTML, I put that in my head tag and I'm done, right? And similarly, I can do this for any number of things. So here I have taken the concert's length and I have put that into the title. So you'll see title is title text, and title text has a display number. So it will display that what are the current number of elements in that list, as well as this text which I wanted to show. I can put it on homepage as well. It's the same thing. I just put it on a different route. Right. I think we are pretty much done here. Let me finish my PPT a little bit. Caching, right? Somebody asked about caching server-side pages. So everything up till now is great, but creating pages on server is expensive because you're using compute resources. So everybody, when they send you a link, when they hit a link, you have to create that page and send it to them. And if too many people do that, there can be a problem. So imagine that you have a rendering server and you have multiple users, and a lot of user basically request the same page, or maybe they request different pages to the same server. Your server is expensive, and over time it is going to heat up and it will have complications. And if it has complications, it will not create your HTML pages and send it to your user, so user will not see anything, which is bad experience for your user. And as I said, rendering servers are expensive. So what we do is we do something smart here, and we employ, so a lot of caches nowadays, they support smart Lambda functions, which can say, okay, if you send me an event, I'll clear the cache, or if you, on every 5 hours or 5 minutes, I'll clear the cache and fetch the new page. So we are going to employ a caching layer here. So whenever there's a change on the page, we'll clear our old cache, generate our new page, and cache that new page. So till the time we do this, we will cover almost all of our cases which needs to be done here. So introducing our caching layer. Now, all the users are also going to talk to that caching layer. And remember, some CDNs will be available throughout the world. So in fact, your page is now going to go faster to your user. Because what may have happened is your rendering server was in Mumbai and your user was in San Francisco. And they have to hop multiple levels to get to Mumbai and get the page back, which might be slow. But if it's in a CDN and it's cached, maybe it's available on an edge network in Seattle and be fetched directly from there. And whenever you have a change, you update it and invalidate the cache and send the new cache there. So it's always ready for the user when they want it. So now when people hit the surface of the CDN or the caching layer, it has to make only one call for that page to the server and say, okay, they have something new for me. The rendering server can employ smart techniques or just create a new page and give it to the caching layer and say, here you go, all concerts, this is the new page. And every user gets that. Or if you are smart, whenever you make changes, you can keep your cache filled. So now when user wants a page, they immediately get a server-side rendered page. So they don't have to wait. So now next time a request comes in, you just give them back a rendered page, and you can employ policies there, and you can set the timeouts and when your page needs to refresh. So for example, let's say you're going to see or read some new tweet from a very, very famous person who has like hundreds of millions of subscribers, of followers. So you can create the SSR page which you maybe refresh every 10 seconds, because it's not going to make much difference to a typical user if I see 5.9K likes versus 6.1K likes in 10 seconds. I'll be okay with that. It's not a very critical piece of information. And that will save a lot of money to them because they don't have to render the same page every time a user comes along. So it's pretty cheap to use that. Right. So I think code-wise I've covered it, so I'm not going to go into that now. So as a bonus, now sometimes we will have to create links. Okay, that's frozen. I have you frozen. There you go, bonus. So bonus is auth-based SSR. So sometimes you have to like see if a user is already logged in. The kind of page they see will be different from what they will see as a generic page for everybody. So bad news here, that page only works on cookies, because when you make a GET request, you don't send your tokens. You cannot employ any of your JS-based auth methods, or you cannot like tweak headers all by yourself. A GET page, but from the average browser, only sends the cookies by default. So if you want to make your auth-based routes work, you'll have to use cookies. And a typical architecture might look like this, where the initial GET page will work on cookie. The renderer server has to proxy every request that goes to your API. And the reason for that is the first request that comes, the cookie will be passed to the renderer server, who will ask the API server for details and give back the HTML rendered page. But every future request which comes from as an AJAX request or fetch request has to go through this proxy. It's a pass through that goes to the API server directly with the cookie and fetch that detail, so that you can continue to use your app. It's a little more complicated to set up, but if somebody wants to talk about it or maybe code it up, I'll be happy to help. But typically speaking, if you understand the principles of what we spoke about today, this will be a little easier to get started with. So yeah, that is pretty much it from my side. If you want to follow me, these are my details. Almost everywhere I'm the same. And I have some references in the slides. I'll share these with you for future. And let's now jump to questions.
Okay, before jumping to questions, like guys, if you can fill out this feedback form, so it would help us to come back with better webinars, right? So please do that. I'm sending you the link. And let's start with questionnaires.
So let's see. Why does Hotstar not use SSR for cards and trails? There is a reason for that, and we are fixing it. Hopefully, you'll see that in future. Is there any recording for this session? I think most likely there is going to be a recording. But even if there's not a recording, I'll send you the GitHub link. Let me just fix that link.
There is a recording, Ankush. We will share it out.
Okay, I'll also just post that link. So if you just follow each commit, you'll start having an idea. And in case you have doubt, just comment on that and tag me, and I'll answer. I'll try to answer it for you. Can we use hash router instead of browser router? We are not using browser router on the server side. We're using the static router, because on the server side we cannot see the URL of what the user is looking from the address bar. So it works a little different. We have to fetch that URL from our Express server from the path property, and then put it in a static router, and then it will go to that route and then load the components for it. If we put fetching data and rendering HTML for every request on server side, won't this create a bottleneck instead of doing this on a client machine? Yes, it will create a bottleneck, and we discussed how we can help prevent that with the caching layer, right? We can avoid loading component based on route in server. Universal component can help. Universal component, isomorphic, they in the end are all same. how to handle authentication in SSR. As I briefly mentioned, you use a proxy. So, and you do a cookie-based system. So when the first request comes for GET, you use the cookie to hit your API and get the details and render the HTML page. And from then on, you have to use the proxy to go to the API pass-through directly. Basically, we token in local storage. If you token in local storage, you will have to write JavaScript code to fetch that token from local storage and attach it in a header or a body or a URL somewhere. That will not work because remember, here we want to have the HTML page without the JavaScript have stuff in it. So if you employ JavaScript-based authentication systems, they'll have to wait for the HTML page to boot up into a React app, which will initialize the JavaScript environment, which will then fire your code that gets the token from your local storage, and then it will be able to make a request. And that is what we want to avoid, because then that means all we have sent back to the user again an empty HTML page, and they will have to fetch the details and render the page themselves, defeating the purpose of the SSR we want to do. How to handle authentication, kind of touch that. It was part of business. Yes, I kind of mentioned that user cookies can be accessed on server as well. Yes, like the whole purpose of cookies is when you say make a request to same domain and same port, then you get that by default and you can read it. Can we fetch data from session storage in an SSR page? Yes, we can fetch data. Like as I showed you, we had to create our Redux storage differently and manually fire the action. But apart from that, we can use whatever Redux functions as usual. Yes, okay. How is to split the code and define things that need to be updated? Yes. So the updating part you can put in the JS and make it client only. Like I said, in the server side, you do not have to load every single data. What you can say is, okay, out of these 10 functions, maybe the first 3 are important to load something useful, and all rest 7 we will only load on the client side. So when the HTML page shows, it shows with the data of the 3 functions, and it's useful. And then as your app boots up and becomes a React app from a website, it then fires those other 7 functions and loads that data for you and keep refreshing it like you want.
Ankush, there is a raise hand also. I'm just allowing Apurva to access for the mic. You can come here. Hi, Apurva.
I think he has a black tape on his camera.
Maybe. So, but we're not able to hear you, Apurva. Hello. I think we lost him. Let's see. I'm just withdrawing. Yeah, let's get back to the questions then.
Okay. Where was I? Local storage, data fetching. How is SSR loading the initial phase faster than client-side loading? Because server also needs the right. So Surya, what we can do is when you come to a site, let's say you want to buy an Amazon product, you want to see the page. So it will start fetching the data then. But if I update a new item onto my backend, what I can say is, oh, I just updated a new item. So now we have /item/item ID as a new route that is available. Instantly, we can create the page, not instantly, maybe it takes 10 seconds for that page to get created because of the heavy API or whatever. But this page is now ready before any user is ready to see that page. So maybe tomorrow morning when you wake up and go to /items/item1, because that page was created for you last night when they updated the item list, it's already ready. So the first page that comes already comes with something for you to see rather than it to start when you fetch that page, if that makes sense. Use SSR for static data, dynamic things. Oh yeah, of course. Client doesn't have to wait for the bundle to download. Yes, you're right, Gaurav. Can we do routing in server without using renderRoute and React Route? No. I mean, there might be some other libraries who do something similar, but it's one of the most officially supported ways. The reason we create the renderRoute object, and I kind of brushed over that, so it's good that you asked this question. It's a nice question. If you create those tags with routes, they are pretty static. But what we want is before we go to that route, we want to get information about the components that are going to come inside. So if we create it into an object, like you saw, I did ..app. When I hit that, it tells me, oh, I'm going to load component called home component, and I need this function called load data to load its data. So I get both these two available before loading that component, which is what we needed to do for the server-side rendering. Okay. Eventually, we are using React components only on server side. And yeah, you can use hooks. In some of my functions, I have used hooks. If you saw the code, I think I didn't go. Last question of mine: how to get a job in Hotstar? you can join my coaching group, and we can take it there. So if somebody wants that, hit me up and I'll send that link to you. Have you experienced latency issues while generating rendered code on servers? If yes, how to solve it? There's a render to node stream, but is it really a good solution? So you there will be latency, right? You have to hit real APIs to get the data you need in order to render your HTML page. Render to node stream is different. So render to node stream is when you have a big page or a big details, you are sending them part by part to basically improve your TTFB, right? Time to first byte. The problem is when you are sending your HTML page, by which time your Redux store is updating, the data might have gotten updated. So maybe if it's checking for something like this dot store dot number of concerts, that may not have updated when you already started sending a node stream, because the whole purpose of render to node stream is to start sending data immediately. But here we want our API to give back all the useful data which we want and then convert it into the HTML page. So we cannot use render to node stream. I know it's very tempting because you feel, oh, I can immediately start sending data. But the whole idea of using the SSR app is we want to wait when we get our data and then give the HTML page. Is there
Ankit,
any error case?
there is a
Sorry?
raise hand. I'll just allow mic access to Shubham.
Sure.
Hi,
Hey,
Shubham.
hi
Hi,
everyone.
Shubham.
Yeah, so the one quick question, right? So why you are relying on React for the server-side rendering? Why not on Next.js? Because
Mhm.
that's quite fast. You do not have to write your custom Express servers. You do not have to rely on the
Mhm.
paths. So everything is on place with Next.js, right? And it's amazing, blazingly fast. You do not need to worry about the search engine optimization and other components to be grouped in.
Yes.
So why specifically React you are stressing upon? That's the only question I need to know.
So correct. Well, it's a great question. In your network, how many people know Next.js?
So generally, barely, single digit people I know, like,
Single digit. How
yeah,
many companies do you know out there that are currently using Next.js?
more than 200 plus, including the big
200 plus.
brands, and yeah.
And when it comes to React,
No, so it's again like it's the different type of comparison you're talking about. But even the Google, Amazon, Hotstar, even the supporter Airbnb, and again like the Netflix is also using the Next.js. If you see their job portal site, that is built in Next.js. So the reason when React came into the market, right, it was
yes.
not being used by lots of companies, right. The similar
Hmm.
case is with Next.js. Down the lane, 2 or 3 years later, we can
Of
see the
course.
impact of Next.js in the market as well. Like the Jamstack is the new technology for the India these days because people are not aware of headless CMS and the Gatsby. They just think in a different manner, right? So the
Yes.
only thing like this whole session is amazing. It's really very impressive. I started working with SSR 3 years back, right? So I joined because I needed to know like how you are approaching in Hotstar and how you're understanding it because I'm working with
Hmm.
a fintech company right now and we have the typical use cases of where we are dealing with lots of data and again. So the one thing I like to know, like what's the standard progressive web apps, which is desktop oriented and which needs to be, server side rendered. So just like the Spotify and the Twitter kind of stuff.
Yes. So first part, why React? So Next.js actually uses a lot of the concepts which I spoke about, but it does it under the hood. So you don't have to set that from scratch. React
Exactly.
tends to have React tends to lack a few conventions, so we have to learn how to put those pieces together. If you use something like Ember.js, fast boot, you almost have to do no setup. So it
Mhm.
depends on the framework you're using and what use case it's solving for you to include it. But the concepts basically under the hood are the same things: waiting for the data, rendering on time, finding a function to convert, looking for security. Next already has that in place because Next came after React. React had to undergo that evolving process in order to create this system. So Next looked at it, saw the mistakes it made, saw the kind of problems people had, and put it up in a better, more nicer fashion. But everything in the end works on concepts, right? If I know these concepts, I can tweak them. I can probably hook into the network in the Next.js code also and change a few things here and there, and maybe create another new framework. So
Yeah,
it depends.
exactly.
Like, yeah. And the second thing is on progressive web apps, they are very useful. But again, like when you have a code base that already exists, but you want to improve on it instead of creating something from scratch, then you need to like start enhancing it instead of throwing it away and starting from scratch. Because with progressive web apps, there can be a few unknowns as well, right? You start using service workers, and for some reason, some browsers don't support that, and now you're stuck. So you still want to keep code that includes everybody in the process, and it's in a way that you can extend into the new features.
Yeah. So, and one last question, right? So that is towards the data visualization part, because I'm more into the data visualization part also. So when I generally rely on SSR, if not even in the React or in Next.js, the data visualization is a pain for me always, because it deals with the DOM, right? And the DOM is
Yes.
not present, and it's totally blank. Like in that case, how to approach in that? So I found some couple of hacks, the way arounds of that, but that is not the standard approach. So if you have some idea, right, how we can rely on that part in terms of server-side rendering with the initializing bootstrapping of the data visualization parts.
So I did that using shoeboxing, like I showed you, where you create whatever data you're using for the visualization and you send it across. I worked on a hobby project, so it kind of worked fine. But I think that is the only way I can think of right now, which I can send data which is already ready for us to show in the DOM. Because as I said, it's an HTML page, right? So you have very limited things you can work with. And I rather use something that all browsers support natively than try to create my own custom solutions.
Yeah, so the same thing I did, like I saved everything in the cache after the first interactive session of the meaningful paint, right? And then I was
Hmm.
reading from the cache, and again, like the DOM was there, but some hacks was there, so it was working. But again, that thing is still needed to be figured out, like how we will go with the panel data visualization in terms of SSR, right? Because in CSR it is quite easy, but
Yeah. Data visualization tends to be a hard problem anyway, right? Data visualization, games, anything that is very DOM heavy and needs a lot of user interaction. You cannot, like SSR is not a one size fits all solution. It's there for a limited number of use cases. I wouldn't even say that you should be using SSR everywhere. You have, again, like I said, you have to see what purpose it solves for you and if it makes sense. Like you can even do SSR only on a subset of routes. Don't do it for every single app which you have out there. If I'm using a banking app, I might be okay waiting for 3-4 seconds because I want to see my money, right? So no point optimizing it. But if I'm booking a ticket, I want to get to it as soon as possible before I lose the connection. Or if I want to like see somebody's tweet, which I may not see ever, and the social network loses users and views, then it matters. So it again depends on the context of the problem you're solving.
yeah, so one thing before my call. So the way SSR works, right? So it depends on the routing paths. The first routing, which gets load on your browser. Then why not to rely on the client side path? Because once your first initial page would be rendered, right, it would be search engine
Mhm.
optimized also. From that time onwards, you neither need the search engine optimization, you neither need any kind of server interaction. So from that
Mhm.
point onwards, you can rely on CSR itself, which will give you the all frequent data fetching, for your any type of application. So suppose if approach is like B2B2C kind of application, right, where you get to log in and you'll see lots of stuff, but again, it's not B2C directly. So in that cases, I find it fairly enough to rely on CSR plus SSR kind of hybrid
Yeah.
situation.
Like I said, based on the routes, you can do SSR as well, right? You can in your cache if it's there, you use it from the cache. Otherwise, you don't. So
Perfect.
obviously, like solution will work.
It's
Cool.
thank you for that. It's still thumbs up for that this session, right?
Thanks. Thanks.
Thank
Glad you enjoyed it.